All right, so the recording is live. So as we were saying, we are discussing about GETLINE. Let me see the into simple shell. Okay. All right, so let me decrease the font. So we want to create a file called getline.c, right? So let us include, like from the manual, let us check again. What do we need to include? We need to include our stdio.h, right? So let's include that guy. Then I can start my main program now. I might decide to pass in void here. Then I can decide to return 0. Because of our time, I will need to be very fast. So we said getLine will help us to read from a string. So I have to declare where I want to store whatever I'm trying to read. Let me declare a variable called store, and then I want to initialize it to null, just like written here. It says that if you initialize it to null, which is the first argument, asterisk line PTR is the value at PTR. If it is set to null, and then my n is set to 0, so I'm going to say int, I'm supposed to use a semicolon, so I'm going to say int n, or I can just say int size equals to 0. Then if these two conditions are met, then it says that what it's going to allocate memory. It's going to allocate a buffer for storing the line. So let us see. So I can call my getLine. Yeah. So it takes in 3 arguments, which is my line PTR. And you can see a character pointer. So that is the address of what? A string. You can't see my screen.
I'm seeing the screen, but it's freeze. I'm not seeing your screen.
I can't hear you. You are not seeing what?
I guess it's his network. Your network is bad, though. It's not from your office. It's no network.
Okay, so let me continue then. So the next thing is what? A size underscore t. So I shouldn't even use an integer. I have to use exactly what is specified here. That's a signed size underscore t. So I'm to use that here. So a signed size underscore t. So I'm going to pass in the address of this guy, which is my word size underscore t. So I should put an underscore there. Size underscore t. Size, sorry. It should be size. It should be this guy. The address of a size underscore t data type. So address of size is the same thing as address of a size underscore t data type. Then the next thing is what? My stream. So I can pass in my standard input because I want to read from standard input. Yeah. Now I want to set a condition because it says if it fails. I have to actually check if it fails. You might want to print maybe an error message, or you might want to free your you would want to free your store, which is this guy, because it's going to manually going to automatically allocate memory for this guy. Even if it fails, it says that what? On failure, where is it? It returns the number of, but if not, where is it? It's supposed to, I'm looking for where it says if it fails, we have to manually free the memory. Okay, I can't find it right now, but we checked it the other time. It says that if it fails, then it will still allocate memory for it. Okay, you see, it says this buffer should be freed by the user even if getLine failed. So basically, that's what we are going to do. And it says it returns -1 on failure. So I can have a condition here to check the return type of getLine. So I can declare a variable here just to have that. So getLine returns a signed size underscore t. So I need to declare another one here and say size underscore t, and I can say get return value, right? So I might decide not to initialize this guy and say get rv return value equals to getLine. Whatever getLine is returning, then it should store it here. So this line is actually going to read something from standard input. This is my stream that I specified here, which is this guy. So it's going to read something from standard input. And then I can now set my condition that if get rv equals to what? -1. Meaning if it fails, that's what this line is saying. If get line fails, then I would want to do what? Free. Let me have my brackets here. I would want to free my store. As well, I might decide to exit. That's exit failure. Because I'm using my free function, I would want to include my standard library. Because that's where we'll get this guy called free. Okay. So just to be sure, if it happens to work, so let us print out whatever it is entering. So let's say you entered, then your %s, where's my %s, yeah. So I might want to print out a new line, something like this. So you entered %s, then I need to specify my store. So yes. Then after I'm done with everything, I still need to free my store. That's after I'm done. If it doesn't fail, that means it's not going to check this condition. So I still need to free it here after I'm done with getting the command, and I've used it to do whatever I want to use it to do. Then I can now free it at the end of my program. Then my program will terminate at this point. So let us see and check this our code. So let me see, gcc getline .c -o, I'm saving it inside G, and then no errors, then G. So you can see my cursor is blinking. It's expecting me to actually enter something. So I'm going to enter ls -l, and then it says you entered ls -l, and I have my output here. This space I have here is because of this my /n that I have here. So let me try again and run this file, ls -l. So after entering this, it came to this line, printed this out, then a new line, then my prompt again. If I remove this new line, let's see the kind of output we are going to get. So I want to save this guy again, and then I want to rerun this guy, ls -l/tmp. It says I entered ls -l/tmp. Now can you see something is happening? I didn't how would I put it? I entered ls -l, then here I did enter a new line, but GETLINE read everything including my new line, because after typing this command I pressed enter, right? And GETLINE returned this command with the enter I entered, like the enter button I clicked on my own keyboard. So it read everything together and stored it inside this particular buffer called store. Yeah. Now on your command line, commands like this, ls -l/tmp, if you actually pass this command, because this command that we are getting, there are a bunch of executables, right? Like at least this guy is an executable file. If you get this command like this and then you try to process it, you are going to get an error. Why? Because you are passing in a /n. This is a /n to this command, which is actually wrong. What you need is your ls -l/tmp. You do not need this new line to be printed. Or even though you are reading it, your GETLINE is going to read everything by default, but you don't need the new line. So you should find a way to remove this new line from your from your string, so that it is not going to actually get, you don't need this new line. The only thing you need is the redo command. Here I printed out my string, and my string by default has a new line in it. You can see if there were to be no new line, I'm supposed to get my prompt on this same line, just to show you that the way GETLINE works, it is going to read everything including your new line, and it's right here inside the manual. They wrote it somewhere there. we discussed about this the other time. Let's see if I can see it. Okay. Okay, no, it should be up here. Let's see. GETLINE. Okay, yeah, I think they only hinted us here about that. How GETDELIME works. GETDELIME is going to remove, I think it would remove the new line. You can see it's going to remove the new line, but GETLINE will not remove your new line. It's going to read your new line. So I think this was where I saw that. So what can we do to actually remove the new line? Because this command, we need the raw command, not the command with the new line, based on what we discussed yesterday. So how can we do that? Let me just ask this question. I believe I'm still on the call. Okay, yeah.
So we can use the argument, command line argument.
Okay, so how will that work?
We simply, if probably we don't know, if you want to indicate that if you have a specified number of arguments you're expecting, then probably you can do it manually. Else, if you don't have, then you have to loop over it by, so that you can access all the arguments in the argv variable.
Okay, I get your point. Olumide, you have something to say? Pastor George, your hand has been up since.
Okay, I think we can set the limit to new line, something like that. I think that was about what we did yesterday, right?
So how can we do that? And where is the idea of the limit coming from?
From the lesson yesterday, where we did some that to do with an Vivian O is a girl, something like that. So we set the limit yesterday to O.
Yeah. So which function did we use?
That we could tokenize the.
Exactly, that's the right word I'm expecting. We need to tokenize our command. So you use GETLINE to get these commands. You don't process the raw commands as they were. You need to extract the useful part of the command. GETLINE is reading ls-l with a new line. You have no business with new line, so you have to still process this input, this command you've gotten. And what will you do? You have to tokenize it, and you have to specify your token, which is your delimiter, to be a new line, meaning that it's going to split your command. Anywhere it sees a new line, it's going to just stop and give you what we have before the new line. So basically, what we do is that let me print here and say okay, no, let me have a print statement here and say printf, but then it's going to should I say look somehow, but then let's just do that before tokenizing, then let me just have this, then I can print another statement and say printf after tokenizing. So the person that did mention about argv, basically our arguments vector and argument count might not really be applicable here, because we are not passing any arguments or main. We are just using this GETLINE to read from the stream, which is our standard input. So our string talk will be more useful in this regards, as per splitting the commands and giving us the useful parts that we need. So we can say after tokenizing, then let me put a new line here, then after tokenizing, this is it. Oh no, so I'm going to call my string talk, right? So string talk, we use our string talk, then the first argument to my string talk, let us check again, should be your string, then followed by your delimiter, just so, because of those who were not here yesterday. Your string talk is going to return a string. A string is a character pointer in C. So the first thing you pass into your string talk is your string, followed by your your delimiter. So I'm going to pass in my string. What is my string now? Which is my store. That's where the GETLINE is storing. That's where GETLINE is storing whatever the user is entering. So I'm going to pass in store. But you remember, GETLINE is going to I said GETLINE. Your string talk is going to actually it is going to, how will I put it? It can potentially damage your string, because yesterday we did discuss that after reaching each of these delim, depending on how many delimiters you have in your string, it's going to append or put in a null byte there. So it is going to destroy your string, your original string, or your original buffer. So you might want to make a duplicate or a copy of such a string. You can use your string dup function. I think we did the underscore string dup function. String duplicate, you can duplicate it. But because I still don't need this guy, there's nothing I want to use this guy to do for the sake of this class, so I'm not going to duplicate it. But if you, in your own shell, you would need to actually duplicate this guy, then you might want to duplicate it before you pass it to string talk. So I want to say character pointer temp. I want to name this guy temp. That is temporary. So I can say temp is equal to whatever getLine is returning, and whatever string talk is returning. Oh, I'm supposed to pass in store here, not string talk. So this is store, and this is my delimiter. I can come here too and say character pointer delimiter is equal to this guy. But instead of declaring another variable, let me just pass it manually. So I just pass in a new, no, I pass in a space. I should pass in my /n, which is a new line, right? So when I do something like this, I just love it when my screen is so when I do something like this, I want to print out, this is after tokenizing, right? So I'm tokenizing with a new line. Then I want to print out the same thing I printed at the top. You entered, then with my %s, then I'm passing in my, this time around is temp, because temp is now the new tokenized string. So something like this, I should pass in. Now I'm not putting in a new line. So let us see the output. So you entered %s, no new line. Okay, so I believe you can see the full code. Let me reduce the font so you can see the full code from your hand. Alright, so this, I think we are good to go now. So let me save this and let me rerun my C file. I'm having, it says this is implicit declaration of this function. I didn't even get the correct spelling, but I didn't include the header too. So I should use strtok string talk. Then I should come here and include the library called string.h, because before I can use that guy, I need to include that. The string.h is inside the manual, so it is gotten from there. So I just cleared my screen. I'm running it again, no errors. Then G, then I should enter something ls-l/tmp, and you can see before tokenizing you entered ls-l/tmp, right? After this command, after this my string is printed a new line. That is why after tokenizing is right here on a new line, and it says you enter this. That I've tokenized now, that remove my new line character at the end and give me my original string. That is why I have this, and I don't have a new line, unlike here that after printing out the string itself has a new line. That is why the next thing that I'm printing is being printed here, right here on a new line. But now the new line character has been removed, so this is the raw string that I would now process and actually use in my own shell, and I have my prompts here being printed. So this is just the, should I say, the basic logic behind getLine, and what you need to take care or take note of. You should always remember that it will append a new line to whatever it is reading from standard inputs, right? So you want to undo that, because it can potentially introduce bugs into your own program. So that's for that about getLine. The next thing we'll be discussing about tonight is the, let me check my recording if it is still on. Okay. The next thing we'll be discussing about is our fork function. I would try to make this as explanatory as possible. So what is fork? Basically, let me just exit this file. and let us create another file called frog.c. So let us stop here. So let us check our man. I think that's man 2 fork or something. Oh, we are checking our man one. Why is my caps lock on? So we are checking our man one. I think that's man 2. Yes. So it says that what creates a child process. You remember the first series of this shell, we did discuss about what child processes, or we discussed generally about processes. So this is where the knowledge of processes and all that comes in. And I can remember someone did ask me then that what if you are trying to maybe create a process and it fails, and I told the person to calm down till when we start discussing processes, then we'll not discuss this. You were the one?
I asked you that.
Were you the one that asked the question then? But whoever asked the question then, I think the question would be fully answered when we go through this manual together. So what is this function called fork? It basically creates a child process. That's basically what it does. It will create a process. And like we said then, if a process were to be created in a currently running process, the newly created process will become a child process, and the formerly running process, that is the process that is running, or the light that was running initially, will become a parent to the newly created process. So the idea of parent process and child process comes in. So to use this particular function, we would need to include these two guys. Let me check if I'm still on this call again. Okay, I think I'm still on the call. So we would need these two guys to be included, our sys types and our uni std.h. We need to include them. Then the return type of our fork function call is a what? A PID underscore C data type. Then we need to call the function itself, and we need to pass in void. Basically, it means nothing. That's void, nothing. So it says it creates a new process by duplicating the calling process. The new process is referred to as the child process. I think this was what I mentioned just now. When it creates a new process, it's referred to as the child process. And the calling process, that is the process that is creating a new process, is referred to what as the parent process, just as when a parent would give birth to a child. So that is basically what it's saying. So these stuffs here, you can on your own go through them and try to make sense of it and what they are trying to say. Basically, it's just saying that the newly created process is very, very identical to the parent process, but there are some minor differences, and that is what is being discussed here. But for the sake of this class, we have no business with the minor differences between the parent process and the child process. What we're interested in now is the return value. So we need to check what it is returning. So it is the return value that will help us now to know how to handle it. If it fails, if it is successful, whatever is happening, then we use that to actually know. So the return value, it says on success, that if it is successful, the newly created process has been created, that is the child process. The PID of the child process is returned in the parent. So at this stage now, I would want us to pay rapt attention, because things are about to get real now. If you do not understand this concept, then it will be very, very difficult for you to actually try to write your own shell. So we need to understand what is going on here. The return value of fork system call. Come and see. Let me show you again. See. The return value of fork is a what? A PID underscore T. And remember, when you started processes, to get processes, they are stored in a PID underscore T data type, right? And we use our %u to print it out to show that it is unsigned. Now, you can see your fork can potentially return a process ID. Now, going back to the return value, what will it return if it is successful? It says it will return the child process, the PID of the child process, meaning the process ID of the child process, that is the process ID of the newly created process. It is going to return it to the parent, and 0 is returned in the child. So these are two things. If it is successful, for the parent, that is the process that is calling this fork system call, it is going to return the PID of the newly created child to the parent. But if it is successful, we are still talking about successful, it's going to return the PID of the newly created child to the parent. But to the child itself, that is the new process that was created, this our fork system call is going to return a value of 0 to it. If you understand this fact, then I believe we're on the same page. We are good to go. It says on failure, it is going to return -1 to what? To the parents. And it makes sense. -1 most times used to designate failure in C. And no child process is created, which yes, it doesn't need to return anything to the child because the child is not even existing. That's if it fails. It's only when it is successful, then we have two processes that will be running. One, the calling process, which is also called the parent process, and two, the newly created process, which is what? The child process. So these two processes, they have different return values for this fork system call. Please, I want us to understand that it has two different return values if it is successful, because we are going to use this in our code now and we are going to, play around with it. But if it is not successful, if it fails, only one return value, and that will be returned to the parents, which is the process that is calling the fork system call. It's going to return a value of -1. All right. So let us try to write something to actually explain the concept of the fork system call. So I'm going to start as usual, so let's see what are the headers we need to include so I will not get errors again. So I have to include my words, sys/typs.h. I think this sys type is just telling us that we have a directory called sys. Inside the directory called sys, we have a types.h file there. That's basically what that is saying. They are specifying the full path. Should I say no? They are just specifying the path where we have this file called types.h. Hash include. You understand this better when you get to your Airbnb clone projects. For when you start Python, you understand what all these things mean more. We'd appreciate it. Just pay attention to what we are learning now and enjoy the process. This project is actually interesting. So we have our sys types, we have our UniSCD. So let us start our main program. Okay, I have a typo there. So this is our main program now. So I would have my return value. Okay. Now, so let us start with our code. We would need to declare a variable because we want to call this function called fork, right? We need to declare a variable that has this data type, right? That is going to store whatever fork is returning, because we need the return value. You don't just call fork without actually storing the return value somewhere. You need it. So we have a PID underscore T. I would need to type that PID underscore T. Then I can call it fork RV. Fork RV just stands for fork return value. I want to make sure this variable fork RV is turning whatever this our system call is returning. So I'm going to name it fork RV for clarity. Wait, I think okay, yeah. I'm going to name it fork RV. So at this stage now, let me print out a message and say, before I want to call the fork, for example, before calling fork function. So I'm having a new line here. Then I now want to call my fork function, right? It is a void data, it takes in the void argument. So I want to say fork rv equals to my fork. So me calling it now, at this point, I'm doing something. I'm actually doing something. It says it's what? It creates a new process. So at this point now, this line 11, that's during the execution of this program, a new process would be created. Basically, a new process would be created. And let me try to print out what fork is returning, because we don't know, it might fail and it might not fail. Let us go and check the return value again. Where's the return value? it says it will return -1 and the PID of the newly created process. Yes. So let us try to check the return value. So it is that one we'll use to know if it's actually passed or if it fails. So of course, if it fails, I'm going to get a value of -1. That means fork RV will be -1. So I can have my condition. If fork RV is equal to -1, so I can do something like this, then I would know that it fails, right? If fork RV equals to -1, then I'm just going to print an error message. We use our P error, which is defined in my stdio.h. I can say fork or child creation process field. I can say child, or let me just say process creation field. I can have an error message of this format. So I might decide to add a new line here. It says that child creation process field, and I can return -1. So basically, if this process is successful, this line will be skipped. Now, after this my if condition, please, you can help us mute your mic if you are not speaking. I can now print out an error, a printf statement, just to show that okay, after fork, that is after calling fork, then I can print this out to the screen. So this one before calling the fork function, then this one after let me see, after calling fork function, then after calling it, we have two possible values, right? That's if it's successful. We have two possible values for our fork RV, which is what our fork is returning. What are the return values? Let us check our manual again. It says it's going to return where is it? On success, the PID of the child. Good. It says it is going to return the PID of the child to the what? To the parent. So that means fork RV is going to have a value, and the value is going to be the PID of the newly created child. It will be stored inside fork RV. But then it did say fork RV is going to get another value again, which is 0, which is the what? The inside the child process. So I'm still going to analyze the difference or how this code is going to run. But first and foremost, let me just print out this guy to the screen. Then I'm going to still modify this code again. I'm still going to modify it to even make it more clearer. So let me just print out fork is percent u, that's unsigned, or no, not fork self, fork RV is percent u, then a new line. Now see what is going to happen. Let me explain this before I run it. This is it. Let me tell you how your compiler is going to read this code. On getting to line 1, it's going to include this necessary headers, blah blah blah. On getting to line 2, then your program is starting. Yeah, your program is starting. Then it says this. It gets to line 7. You are declaring a variable called fork RV, and it has this data type PID underscore T. Then on line 9, it's going to print this out to the screen. It's going to say before calling fork function, then on a new line. Now, please pay attention to line 11. On line 11, you just created fork. I just called this function called fork. So let me put a comment here and say 2 processes are now running. Please let's just put it as this, even though this might not be 100% entirely correct, because we don't know if it will be successful or not. It can potentially fail. But if it happens to be successful, then this would be correct. 2 processes will be running. Now, the process that was running from line 1 is the parent process, because like we said, if you start running a file like this, dot slash, let's just say exe, a process will be created for this file, right? A process will be created for this file. It will be loaded in memory and it will get a process ID. That is why, remember when we did get PID, it's going to print out the process ID of this particular instance of execution of this file. Now, on line 11, when you call this fork system call, it is going to create another process by default, but the effect of the process will not be seen immediately. Like, it will not be instant. You might not see the effect. So let's assume like you are in a race, just like you would have let's say in a relay race this time around. Let me confirm if I'm still on the call. Okay, so let's assume you're in a relay race. In a relay race, would usually have like 4 runners, maybe the first person that is running, the second, the third, and maybe the anchorman. I think the anchorman is being referred to as the 4th runner. So when the race starts, immediately the whistle has been blown. The first runner would have to start the race. The last runner would not start running immediately. It will still have to wait for when the 3rd runner would have to pass the baiting, or when the 3rd runner start getting near, then it will get prepared to start running and collect the baiting, and then it will kickstart this race. But let's assume that the 4th runner would not run at all until he gets handed the baiting, then it will start running. So the same thing works here. Your child process that you just created, even though you've created it, will not start running until, as it were, the parent process has handed it over the baiting. So what am I saying? When we get to line 11, a new process has been created, but just assume it is still waiting for the parent process to execute or hand it over the baiting, then it will now start running. So by the time we get to line 13, we are still running as the parent process. Please, let's get this fact straight. We are still running as the parent process. We have 2 processes, but the other one, which is the newly created process, is still waiting. And we said the newly created process and the parent process from the manual, they are similar. Like, we are almost similar. They just have minor differences, which might not be noticeable in this our code. So line 13 is going to run as the parent process, and in the parent process, only when fork fails, that's the only time this condition can be true, right? So line 13 is going to check this condition. If it fails, then it's going to print out this error message to the standard output, right? It's going to print it out, then it's going to terminate by reaching this return 1. The program would end. But if it doesn't fail, the parent process now is running. The parent process is going to check through this condition. If it's false, that means fork is successful, right? So it is going to come to line 19, and your parent process is going to print this to the screen. You are going to see it right here on the screen. Your parent process is going to print after calling fork. Then it's going to print. Then it's going to execute line 21, and it's going to print out fork RV. Now the question, what will be the value of fork RV in the parent process? Because now it is still the parent process that is running, right? So let us check what fork will return to the parent. It says it will return the process ID of the child, which is here. That's on success. Where is it? On success, yes. The PID of the child process is returned in the parent. Now, like I said, as we are in a relay race, the parent is going to run first before the newly created child will be handed over the baiting. So it's still the parent that is running. The child is not yet running. So the parent will now print out this line. So what is the return? What is the value of fork RV in the parent? This is it. Here, right? The value of fork RV will be what? The process ID of the newly created child. So on line 21 now, we are expecting that it is going to print out the return value. It is going to print out the process ID of the child. That is what line 21 is going to do, because we are running now as the what? As the parent. Then after line 21 has been executed, line 23 will now get executed. And what is the meaning of return 0? Return 0 means terminate or end my program. So your compiler is going to get to this line and is going to terminate or end this program. But remember, we have 2 processes. The first one that terminated here is the parent process. That is the original process that was running. On being terminated now, your the newly created process will trigger. It's almost as if you have handed it over debating. On your compiler hitting this return 0 statement, your child process, there's something that is happening under hood, though by the time it gets to return 0, something is going to happen. They call it it's going to get a signal. We've not discussed about signals, but then it's going to get a signal. On getting that signal, it is going to start running. So let's assume the signal is like debating. The third runner is now handing over debating to the fourth runner. So the fourth runner now is now getting debating. As soon as it gets debating, it will start running. So on getting to return 0, the parent process has terminated and it has ended. The child process will now start running all over this program, but it is not going to start running this program from line 1. The child process is going to start running this program from immediately where it was created. Where was it created? This line 11. So your child process is now going to start running this program all over again, but now this time around from where the fork system call was called. So your child process is going to come to this if condition, and it is going to check. Obviously, it can never be -1 in the child process, because from here the child process only has one possible return value, which is what? 0. So your child process only has one value called 0. And in the child process, fork RV is going to get another value, as against in the parent process, our fork RV has a value of process ID of the newly created child. But now we are now running as a child, and the child would have a value. That is, fork RV is going to have a value of what? Of 0. So this condition obviously is false for the child process now. Then your child process is going to print out this printf statement. You're going to print this out to the screen. Then your child process is now going to print out the value of fork RV, which is what? 0. On printing it out, return 0 will be it. After hitting this return 0 statement, then your program terminates, it ends. And that's how this program is going to run. So, what am I expecting? I didn't mention earlier, during the first instance of execution of this program, that is the parent process, right? When it is running, by the time it hits return 0, I'm expecting my prompt to be printed out to the screen. After my prompt has been printed out, then my the newly created child process will now start running from line 11. By the time it runs, it's going to redo everything we have here. Maybe what I'm saying might not make sense, but let us run this program. I just want to explain before running it. So when I run it, the output will not be strange. You'll be able to connect the dots. By now, it might be confusing.
So we'll have one error.
You what?
We'll have one error. You didn't pass the
Can I
argument for the...
My what? I didn't get that.
You didn't pass the argument for %q. You're supposed to pass fork RV.
Oh.
In the last printf statement.
Thank you. Thank you. Thank you very much. Yeah, the argument is fork RV. Sorry. I didn't pass that in. Thank you very much.
And also in your header file, in your header, yes, there's a mistake there.
I can see that. Thank you. Okay. All right. So.
hello? If I may ask, we talked about the parent process being executed. Does the child become orphan now after the parent? The parent process being executed or terminated, does the child become orphan?
Yes. The child will become an orphan process because the parent executed and it hits the return statement before the child. So it becomes an orphan process. You are right. So let us run that. Let us see the output. So I'm running my G. So why is nothing happening? Is it my terminal now? But okay. What am I saying? It's expecting me to actually type in something. Oh, this is my GETLINE file, not my fork.c file. I'm running the wrong file. Oh, okay. Let me just type in something random. Okay, I want to run my what's the name of this file again? Fork.c. Yeah. So I want to run my fork.c file. I want to save the output inside F. Yeah, it says I have a lot of errors. The first one is on line 9. What did it say? print f implicit declaration. Oh, I didn't include my hash include stdio.h. This correct? Okay. The next error is from okay. It's telling me to actually include it. Okay. So I think that's the error. So let me clear my screen and rerun my execute. Okay, good. And then I'm running the f, and you can see now this compiler is not giving me the type of output I want. I did say that by the time it's return 0, I'm expecting my prompt. Let me run it again. Okay, it's behaving funny actually, but this shouldn't be the proper way it should but it's just my own terminal. So let us check the output we have here. Let me try and explain again the explanation I did earlier and see if it will make sense now. So this is it before calling fork, right? Which is this guy. Now my program started from here. It started from line 6. So before calling fork, which is the output we are seeing here. Now this is the parent process that is running. This is the parent process. This first output is the parent process, right? Now I created a process here, but the process is not yet, it is running, but it is not yet it is still waiting for the parent to finish running before it will start running. Let us just use that kind of language. It is still waiting for the parent to run because it doesn't want to be forward. It wants the parent to finish running. Hey, after it has finished running, it will now start its own execution. So at this point, the parent created a new process using this fork function, and if the function is successful, if the newly created process the process has been created, then from the manual it did say that it's going to store the process ID of the newly created process inside the parent process, which otherwise can be called the calling process. Calling process, parent process, they both mean the same thing. Calling means something that is calling this fork function, and it's only a parent that can potentially call fork because it is ready to create a new process or create a new child. So inside fork now, it's going to store the process ID. The process ID can be anything. We don't know. It could be any value, but of course we know it is not a negative value. So this condition now will be false because a child process has been created. Now line 21 says printing after calling fork function, which is what we have here. Okay, I didn't have a new line there. That is why the next printf statement is on the same line as this first one. I'm supposed to put a new line there. So this first our line 21 now, this is our line 21. It says after calling fork function. Then line 23 says fork RV is passing to you fork RV. Now it says fork RV is what? 12558. So yeah, what do we have here? Can someone tell me what this value is?
Good evening.
Come again.
Good evening.
Okay, good evening.
Good evening.
Yeah.
Yeah. From the manual you showed us, the return value will be what? One will be on the what? On the PI on the what? The parent calling function. Then one will be what? From the child. I think the first one, which is 12558, is the one on the what? On the parent, the return value from the what? The parent. So why the 0 is to tell us that a child has been...
Wait. We are not yet here. We are still here. So let's discuss about this one first before we jump to 0. Okay. This 12558, what specific value is this? That's what I'm asking.
I think that one is from the return parent.
What value is this?
Process
ID.
This is the PPD.
I think this is PID for the child.
PID for the child process.
On the parent.
That's PID for parent.
Yeah, no, for PID of the child on the parent process.
Yes, the first one is PID for the parent's process. That's 12558.
No.
While the 0 is child.
No.
Why 0 is what for the creation, the successful creation of the child.
Yes.
I thought on the manual you said
no. You guys are not following what is on the manual. You are not following what is.
I think the manual you said the parent returns the PID of the child, so that basically, all of that thing becomes the PID of the child.
You can see that. Show us the manual again.
I should show you the manual again, ba.
So that from there, maybe when we read the manual, we can figure out the result.
Oh, can I
let me open the manual again so you see. Let me go down to where we have the return value.
Return value.
Okay, can you see it says on success the PID of
Yes,
the child
PID
is returned in what?
returned in parent.
So the return value of fork will be what in the parent? Let me cut this file again. Okay, yeah, this is it. This is fork, Abi, and we are still running as the parent. So what will fork return in the parent? What will be stored inside fork RV based on what we have in our manual here?
The PID of the child.
Basically.
The child.
So this first value we have here is called the PID of the child.
Of the child process.
Yes, that is the newly created process. This is the PID.
Yes,
It will be returned in the parent.
Why the 0 is to return on the child?
Exactly. So it will now return if the child is running now. Fork RV, let's see the manual again. It says that it will return 0 in the child. So, but we've not yet gotten to this place. We've not yet gotten to this
that
place.
That is a successful creation of the child.
Yes. So, let us veer into our file again. Now, we are still running. The first thing we did was this one, which is this output. And let me clear my screen. We run the executable. So the first thing that was executed was this, our line 11. Then this condition was false because the child was created, so it was false for the parent. So on getting to line 21 now, it now says after calling fork function, then our line 23 printed out the return value of fork in the parent process, and it happens to be what? Where is it? This is it. And it happens to be the process ID of the newly created child. Then the return 0 statement was it. Then the process terminated. That is the parent process. It terminated. Our control will now go up back to line 13. So on getting to return 0, it has handed over the bits into the child. Where did we create the child? Here. So our control will come back to this line and it start running again downwards until it ends. So it's going to check this condition. Now this is the child running, not the parent. The parent has already died. Now it is the child that is running. So it is going to check what's the return value. Obviously it can never be -1. It is always 0. That's if control eventually gets to this stage of checking for the child process. Obviously it will be 0. So fork RV can never ever be -1 in the child. It is only the parent that can have two possible values of -1 and process ID of the newly created child. But in the child, if it is obviously it is successful, obviously it will be it will always be 0. So this condition is false, like it is useless for the child. It will never ever be true. Now it is going to execute line 21 and say after calling fork function, this time around now we are in the child. This is it. This second printf statement is no longer in the parent. This is the child process, the newly created process. Then after printing this out, it is now going to execute line 23. We say that fork RV is what? Now, here, it's telling us fork RV is what? Is 0. Meaning we are inside the what? We are inside the child process. Then the program ends. And that's it. So, let me rerun this executable. And you can see it will always change. The process ID of the child will always change. Just like we know process ID will always change when you create a process. When you run a process, we demonstrated that the first time we started this PLD, and it keeps changing. But this is not all to processes. Let me see my recording is how many minutes now? 53 minutes.
Please, I have a question. Sorry.
Okay, go on.
Hello.
Please go on. I can hear you.
Okay, so out of curiosity, I know something before about the child process now being an orphan. So when the child process exits, like finish executing, what does it return to anything? Like I'm just being curious. Is it like the both processes are now killed, and then what next happens?
Okay. What we just did here is not something you should do in real life. You creating a process and then the process doesn't have a place to return to. There is something referred to as the master process or the init process. this init process is like the father of all processes. So in the situation whereby a process that was created becomes an orphan, then this init process is going to adopt or take up this child process. So it is now this init process or the master process that is going to terminate or that's going to terminate this child process that has become an orphan. But please, in practice, ALX would not want you to do this.
Thank you.
Yes, they would not want you to do this. And there is something else we can see add to this our code to make sure that the parent process did not hit return 0 and then the child process will not start running. We can manipulate our program in such a way whereby the parent process would wait for the child to actually execute before it will hit this return 0 statement. There is something we can do as regards that. Maybe by the time we move on, we are going to discuss about that. But what I want us to do now, I want us to actually make use of this particular return value of 0. Since we know fork RV, that is whatever fork is returning, will always be 0 in a child process, we can actually play and take that to our own advantage and modify our code in such a way that we would write a code and make some printf statements that only the child would do. For instance, let's say here I have a condition here saying if fork RV equals to 0. Obviously we know this condition would only be true in the child process and never in the parent process. So I can say if fork RV equals to 0, I can do printf I am in the child process /n, and then I can say printf then we can even confirm the PID of the child if it corresponds with the return value for fork for the parent process. We can inside the child process. Now this statement will only be true inside the child process, so we can say my you can even say child PID. So let's make it as descriptive as possible. Child PID is percentage u, then our new line, then our percentage u now would now be what? Our fork RV. Obviously this is for the child process. Then I'm missing something there. Why is a colon, semicolon. Then we can decide to print out the parent ID, the PPID, but of course it's not going to be the process ID of this parent because the parent has died before the child started executing. So we are not going to see that init, that master process we are talking about. It's going to give us the ID of whatever adopted this child when the parent died. It's going to give us the process ID. So let us check my PPID of the child is %u. Then I'm going to say get PPID. I'm just going to call the function inside this my printf statement. Then I'm going to, so for my get PID, let me see if we have to include some headers in our code. We would need to include, I think we have what we need. This uni, we need uni. So let's see. I didn't terminate this.
Printer. That is the printer.
Yes, thank you. So I called get parent process ID here. So basically, thank you, printf here. So this condition would only be true in the parent process. Now we'll now say else. Else means if this is false, then this is true. Then if this is true, then if is true, then else is false, basically. So we want to control it in such a way that if it is running for the first time, which is the parent process, it's going to skip this. It's going to skip this. It's just going to come and do us here. Then if we start running again from line 13 for the parent process, for the child process, sorry. When you start running again for the child process, it's going to skip this. It's going to execute this. Then that's all. Then let me put this here. Then I want to indent this and indent this. Then have here this. Then say print here and say something like I am the parent. I am the parent, then new line, then here print something like my PID. Yes, let us print out the PID, or we don't even need the PID of the parent self. We don't need that. It's, but well, okay, maybe we can just do that. Maybe we can just do that, but we actually do not need that. But let's just do that, sha. Print f let me print my child PID is this. So let us print out the child PID. Of course, it will be stored inside fork RV. So for parents, fork RV is the child PID, but for child, fork RV is what did I do here? No. Fork RV in the child is not a child PID. I did a mistake here, and no one noticed that. No. Fork RV is always 0 now. No. I should do get PID. No. And no one noticed that. That's actually a wrong statement. Inside the child PID is always fork RV is always 0 because fork will return 0 to the child. So I am the child process. Child PID is this. It's going to print out get PID. Then the parents process ID is now PPID. But now in the parents, now this else condition will be true. It's going to print I'm the parent. Then it's going to say my child PID is fork RV. So let's see if fork RV is the same thing with get PID for the child. So that's basically what we want to confirm here. And then let me assume there is no bug in this code. So let me save. Let me save now, and let me rerun my program. Okay, no errors. So let me decrease the font. /f. So it did print out something to the screen. It says this is the exact same output I've been expecting. Like after it has finished executing parent process, it's supposed to print out my prompt. Then only then should it start executing child process. It wasn't doing that before, but now it's now working the way a normal shell should work. And I was saying my terminal at times behaves funny. So this is how it's supposed to work. So let us check before calling the fork function, which is line 11, right? Then I'm the parent. Now after getting to line 11, it executed this line, it created the process, but now the parent is still running. So it checks for line 15, condition false. It checks for line 21, condition false again. Then by default, this is true. So it's going to come to this line, and then it's now printing line 33, which is I am the parent. I believe you understand how that is running. Then after printing line 33, it printed out our line 35 and says my child PID is 13349. Now we are using fork RV value to print that out inside the parent process. On getting to this line, our return 0 statement was executed, and that is why we have our prompt to show that the parent has terminated. So after the parent has terminated, the control will go back to line 13 to start the child process. Now it has gotten the baiting from the parent, so it has been given go ahead to execute. It received a signal call, so it is that signal that will trigger the child process now to start running. So the child process now is checking this condition. It is false because it can never be -1. Then it's checking this condition, which is true because always fork RV would always be 0 in the child process. So this condition is true. It's going to execute line 23 and say that I am the child process. Then it's going to execute line 25 and say child process is what? Child PID, I mean. Then it's going to print out the child PID. We are using get PID to actually print this out. Now check, this child process is the same with what the fork RV value for inside our parent process to show that okay, the manual is actually right. For the parent process, the return value of fork would always be the process ID of the newly created process. Then we did our PPID. Now you can see the PPID of the child is what? Is 1. This 1 is the init process I was talking about. Since the parent has died, it has nowhere to return to. That is why it is actually taking the init process, master process adopted this guy and it's ripped it off the process table. So this child process actually returned to the master process, master of all processes that you can have on your terminal, I believe. So it returns to it since the parent process has actually terminated before it completed its own execution. So I don't know, do we have any questions as regards what we've discussed so far?
So the last line you just said, I didn't get that part. Last line about the CPID, the one the process that adopted the child process. Sorry.
Okay. So we have a command. Let me man it. PS. PS is used to give us all the processes that are running, right? So let's try and check this command. Let's try and check this command and see all the processes I have running currently. So I'm going to run this command PS. When I run it by default, it's going to give me a bunch of processes. I want to pass in some flags to it, -EAF, just to like optional flags. You can check the manual for what these flags do. So when I do PS -EAF, it's still going to give me a list of all the processes. In fact, let me come here and let me run it here because it's going to display a lot of stuffs. So let me use the terminal by my left to actually do that. PS -EAF, and then you can see I have a lot of processes, so it's going to give me their IDs. And then checking through this is the process table we are talking about. This process table, if you have processes, newly created processes, is going to append to the end of this process table. You are going to see them at the end here. It's going to display them. You can see the command I ran just now already has a process because it's a shell command. You can see it's already here and it has process ID and PPID. This command now that I ran just now. But now let us check the process that has a PID of 1. Where is it? PID of 1. You can see the root. The parent process ID of this guy. This is it. Master process, which is the init. My sbin /init. We call it the init process or the master process. This is like the processes of all process. By default, when all any process terminates and it becomes an orphan, it is this init process that is going to adopt it and it's going to remove the process from the process table, because now our ./f, we can't see this process again on the process table. We can't see it. We are supposed to see it immediately before this guy, but because it has already been removed from the process table, that is why we cannot see it again. But there is a command we can use to actually see as this guy is being executed right here. It will show here on the process table. That's if you use your wait system call to actually delay the runtime of this program, so we can quickly type our PS -EAF and see the command right here on the terminal. So everything that is running currently at this moment, this is it on my own terminal. So the master process I was talking about, which is the init process, this is it right here. You can see the process ID and you can see the PPID. Now let me do echo $, which is the parent process that is currently running, which is my vagrant. You can see here 3469. So let me look for the process ID that has this 3469. We should see the name. So the first one is process ID, the next one is parent process. So let's just check for process ID, this first guy here, and see anyone that has 3469. Let's go. 3469. Yeah, 30 should be here. 3469. 346. Okay, that's 3000. Oh, I was checking 300. Now you can see 3469. This is the process ID, and you can see it is what? Vagrant. And what's my bash. So whatever is running on my terminal now, or that is running, that is letting this terminal to run, is called my bash. That is why when I do my /bin/bash like this here, that means I have restarted my bash. And when I do my echo $, that is why I'm going to get a new instance, because every time I'm running this my file, I'm getting a new process, and then I rerun my bash file, and obviously I'm going to get a new process ID. But without rerunning the executable file, when I do this, I'm still going to keep getting the same output, because this guy, I didn't rerun it. It's still the same process that is running. But as long as I restart it, the former process that was running will be removed from this process table and a new process will be created. So if I should run my PS -EAF command now, I should still see this guy, but this time around the process ID would have changed. So we can still check that and look for one. This 13,701. 13,007. We can see it down here. You can see /bin/bash, which is this executable file, and it's what vagrant is the current one that is running, and we have this guy 13,701, blah blah blah. So all processes you are running would be displayed. This is the process table, and yeah. So you were asking about one, right? Which process has the ID of one? It is the init process, which is the master process, and this is the PID called one. So it is going to automatically adopt processes that are like orphan. So now, like I said, you would not want to do this on your, when you are writing your simple shell program. You would not want to do this because you creating processes and making them orphans, it's not the best, and it is not allowed. So you actually need to introduce another system call, which is the last, I think that's the last thing we'll be discussing tonight, which is called, we've already discussed about the fork. Now we'll be discussing about the wait system call. So as usual, when we want to discuss check out any command, we are going to check our manual. I think wait is it man2 wait? Let me see.
So before you go to the next function,
Yeah.
I want to ask, what's the difference between an orphan process and a zombie process?
Okay. I'm not so sure, but what I do know about orphan processes is that they would be their parents would terminate before they would be terminated. But about zombie processes, I feel these are processes that are somewhere hanging in maybe on the process table with maybe nothing to adopt them, or they didn't get a signal to return back to the parents, and then they are hanging somewhere on the process table. But I'm not 100% sure the right type of terminology I should use to clearly distinguish a zombie process from an orphan process. But maybe you can maybe Google that or check that, or if someone else has something to say as regards the zombie process, like the clear terminology to use to distinguish zombie processes from orphan processes. But what I do know is that zombie processes are currently on the process table. Nothing is adopting them. They are there. They are like wild, something that is running wild. Just there. Nothing is removing it. It's just there. And it will be loading up your process table. And when zombie processes get too much, it can potentially crash your system. But an orphan process is a process that the parent terminated before it finished its own execution. While I feel a zombie process is a process whereby maybe the parent has terminated, or maybe the parent is still alive, but then it is not getting any signal call to return back to its parent. So it is just there hanging somewhere in the process table, whereas it has finished executing, but it is still there. Nothing is removing it from the process table. So it will keep clogging up your process table when you have a lot of zombie processes, and it's not something you would want to do. If the answer is not sufficient, you can still go and check more on that and get other
okay, thank you. I've understood.
resources.
I've understood. Thank you.
All right.
Excuse me, sorry, on your Vim to the left, can you scroll up a little?
My what?
The Vim terminal screen, the one to the left.
I should zoom in.
No, scroll up. Sorry, I want to see the bottom. The bottom. I want to see the bottom.
Okay.
Sorry.
Let me reduce the font. Yeah, this is the full code.
Okay, because I actually followed the code while we're writing, and I think mine is returning something different.
Where?
Where we have the PPID. Okay, can you execute yours to the right?
Yeah, it will be different. The processes are different.
No, mine is not returning. It's not returning one. I think the one it should for the PPID should be one, right? Is that one?
For the master process, right?
Yes, for the master process. Yeah.
Okay. You should
but
actually
that's-
return one. What's the name of the file again? Fork dot. That's
F.
F. Yeah. Your PPID, that is the
PPID of the
process.
child. Mine says 1,576.
1576. can you do your PS minus EAF and see which particular process adopted it? On your own system, you can check your process table, check whatever process ID that has the 1576, check out the name and see which process adopted it. But by default, it should be the init process that should adopt it whenever it becomes an orphan.
Okay.
Maybe the configuration of your own system is different, but
Then probably the code, maybe the else statement, maybe one of it is out of that else statement, the block. You should check the block very well.
maybe you can check your code very well, but this should be the kind of output you should get on your own
Okay, no
terminal.
problem.
So let us check our manual for the wait system call. Because of our time, let's see, we're already 1 hour into the recording. So the wait, we are basically interested in wait. It says it's wait for process to change state. The question now is, what is a change of state? That's the first question we should ask. Come and see, it is here. Let's see. It says that all these system calls are used to wait for the changes, for state changes in a child of the calling process. So it is used to wait for state changes in a child. Meaning, whenever you are using the wait system call, you would use it in a parent process, not in a child process, because the parent needs to use it to wait for a child. Remember, this is our code. The parent just ran right here and it hits this return 0. It was only then this child process started running, which shouldn't be so. The parent is supposed to run, then wait for the child to finish executing before, so that the child can return to it. Then it is now going to hit this return 0. But that didn't happen. But with this function now, we can actually change the output of this code and make sure that the parent waits for the child to finish executing before it would run. And this is the way ALX wants us to do it, not this particular one we wrote here. So using this wait system call, we can actually achieve that. And what is a change of state? There are, I think, about 3 different things here. It says a change of state is considered to be 1, the child terminated. So if a child terminates, a change of state has occurred. 2, the child was stopped by a signal. That's the signal I've been talking about since, that a signal, it would get a signal. And that is why when your parent process hits return 0, your child process will start running instantly. What is telling it is because it's receiving a signal. If it didn't receive a signal, it will not run. It will just be there. You created the process, but the process will not run. But because the child received a signal, that is why the child started running. That is why I brought in the idea of it receiving a beating. So just view that beating as a signal. Now, this is the second thing that can happen. The child was stopped by a signal, or the child was resumed by a signal. Now, this resumption by a signal, you can view it as what happened here when the return 0 statement was hit by the parent. Then the child that was seemingly sleeping was resumed instantly. As at the time you created the child, you can view it as if it was actually in a state of sleep. It is not running, it is just there. But as soon as the parent process finished executing, it received a signal, then it started running. And as at the time it finished running, it has no place to return to. It became an orphan, and then someone else adopted it. So you can see a change of state is basically 3 things. 1, where is it? A child was stopped. If a child was stopped, then that's a change of state. If a child was resumed, that's a change of state. And if a child was terminated, that's also another change of state. So that's basically what we need to understand about wait system call. And this is the prototype, a PID underscore T data type. Then you pass in wait. Then this one is not void, unlike our what do we call it? Our fork that was void. I will not pass anything into it. Our wait is not void, so it needs the address of an integer data type. So I will come here now. I want to edit this code. I don't need to retype another code, so I'll just come here and say int wait status, or let's just say in status then here I'm going to call in my wait. Like I said, I wouldn't put my wait inside my parents inside my what do we call it, my child process. So I'll put it inside my parents process. I can put it basically anywhere. it could be anywhere inside my parent process where I know my parent process would be executed. So let's say I want to put my weight at the top here. So I'm putting weight, then I'm passing in an integer pointer, which means an address of, yes, an address of what? Status. So what is it going to store inside this status? I think the manual did tell us. It's going to store the exit status, or let's see. It should be somewhere here. What is going to store? Okay, yeah. Someone that was asking about zombie, I think they did mention it here. It says if a wait is not performed, then the terminated child remains in a zombie state. Oh. In the case of a terminated child performing a wait, performing a wait allows the system to release the resources associated with the child. If a wait is not performed, then the terminated child remains in a zombie state. Maybe this is saying that even though the child became an orphan, it could still potentially be a zombie. Maybe that is what this resource is saying. I'm not 100% sure, but we are looking for wait status, right? What is it going to store inside status? Okay, but then it's going to store the exit status or the wait status of such a child. So it says wait returns on success, which returns the process ID of the terminated child. On error, -1 is returned. That's for our wait system call. I'm not saying what status is doing, but maybe I'm missing it. Okay, I can't see that right now, but then it's going to store the wait status of that child inside this variable called status. That is why we need it. So when I do something like this, what do I expect from my code? When I run my code, I believe I'm still on the call.
But you've not included the library, the sys, then / wait.
Thank you very
much. The library for the wait. Yeah.
Yes, thank you. I forgot that. So we need to include this. Hash include our sys wait type. It's telling us we have a directory called sys, and then inside it we have a file called type.h. Okay, wait.h. I think, yeah, that should be it. So basically what this is doing is that when your control starts from your main here, then it executes everything here, then it's going to skip this false, then this else will be true for the parent process. Then on getting to wait, your the child process will be triggered, because this wait means wait for the child process to finish executing. So by the time control gets to wait, the child process will be triggered. So control will go back to line 13, which is the point at which the child process was created, and to start running from there. So it is going to execute this line, false, then it's going to execute this line, this is true, then this will be printed out, this, then this. By the time this is done, then the return 0 statement will be this is going to be false too for the child, obviously. So it's going to get to return 0, then it will now return back to the parent. So control will now start from here, because this was the point where we stopped before the child started. So by the time it returns, it's now going to go back to this point, then this line will be executed, printed, this will be printed, then return 0 for the parents now would be printed, and that is how our program should run. So let us try and run this code now.
No, Mr. Samuel.
Yes.
But I think we've not given any value for the status. We just declared the value. It's like we did not define any value.
Yes, we don't need to put in a value. By default, our wait system call is going to pass in a value there. It's going to put in a value.
Yes, sir.
The exit status of the wait status of this child, we said we are dealing with signals here, so it has a wait status. The status of this particular wait, I don't know the value it would be, but it's going to give
it will be a random value, right?
Yeah, it could be a random value. Let us print it out, Seth. Let's print it out just so you see. Print f wait exit no wait status is, it should be, I believe it should be unsigned. So let me use my %u /n new line. Okay, so let's do something like this. Wait status
We will not pass the argument
of child. Okay, thank you. Of child is then status.
that will be asterisk, Ali. Asterisk status.
No, it's
We are
it's an integer. Here is asterisk status. This an integer pointer. You know, asterisk means a pointer, address of or status. So that's what we are passing into our weight. But we are trying to print out the value of weight. So I just need to pass in status here, basically. So let's gcc the file again. What's the name? fork.c -o, then saving it inside f, and I'm running now. And then as usual, this is going to run the child process. Now you can see it says before calling the fork function, which is this guy, then your control is going to skip this false, then this is true. On getting to this place, it says wait, so it's going to come back to line 16 and line 13. Then this is false, this is true, then it's going to print out line 23, which is what we have here. The child process. Then it's printing out line 25, which is this other guy. Then line 26, which is this other guy. Then after that, it's coming back to return 0. So it has actually returned. So this is going to be false for child. Then it's going to get to return 0. On getting to return 0, the parent process is going to trigger. This return statement is going to terminate the child. And we said that wait will always wait for change of state. Change of state, we said, could be 3 things: when a child was terminated, or when a child was resumed, or I think the other one I've forgotten. Like about 3 reasons. We're given 3 reasons from the manual. A child was terminated, a child was resumed. A child was stopped, Abby? Yeah, or something like that. So your wait will just keep searching. Anytime it changes a change of state or it receives a signal from any of the child processes, you know, it is possible you create like 5 different child processes. Maybe you call like fork maybe 10 times or 5 times. But as long as it receives a signal from one of them, wait is going to trigger the parent process to start running. So by the time your the child process hits this return 0 statement, return 0 is going to terminate. Then wait will be triggered, it will be activated, and that is why this will be printed. It says wait status of child. Where is it? Yeah, is 0. It did put 0 here. It did put 0 here, and it says I am the parent, which is this line. Then it's printed out the child PID, which is this line. Now let us do something. Let us print out the PPID of the child. Where is it? This is PPID of the child is this. Now let us see if the PPID of the child would correspond to the process ID of the parent. I didn't print that out, so let me print it out. My child PID is this, and my PID is this. So I'm going to call fork RV and then get PID. Now this is the get PID for the parent. You know, we're inside parent now, so it's going to return the PID of the parent. So let's see if the PID of the parent will be equal to the PPID of the child, as against before, where the PID was giving us 1, which is the master process, when we did not use our weight. So let me rerun. What is happening? Too many arguments for formats. I didn't pass in. Okay, I should use another
we only
percent.
have one.
My PID.
We only have one placeholder. We only have
Yes. My
have
child
2
PID.
placeholders.
My child PID.
You want to have 2 placeholders
Yes,
at line 37.
I can get you. I already got that. So it says my child PID is %u and my own PID is %u. So let me clear my screen. So yeah, and then it says, let's see, I'm only interested in child PID is this, and my PID, which is the parent. Now you can see, okay, where is it? Okay, sorry, I'm to check this PPID, that is the parent process ID of the child is this, and then process ID now of the parents is actually the same, to show us that truly after this child terminated, it returned back to what's called it, which is the parents. And you can see this is confirmed. And again, our wait status is still 0. Maybe if the wait is successful, it will return 0. Maybe that's what the manual says, but I'm not so sure. But this is the second time of running it, and then it's still this same value called 0. Let me run it again.
So I'm thinking that where we have the printed value, the 34, line 24, 34.
Okay.
You know, we declared int to be int status, no value for it, but we are printing that same status. You know, we have, I thought it is going to be a pointer. It's supposed to be the reference by using asterisk. I'm not sure though.
Inside our printf statement. Is that what you are saying? Okay, let us do something. Let us give it a value. Let me give it 100. And let us try to print it. And let us see if it actually changed. Line 33 is supposed to change the value. That's what your wait system call will do. It's going to save the exit status of this child, the wait status of this child. It's going to save it inside this variable that is an integer pointer that you are passing to it. So I initialize it to be 0 here. And let us see if it will print out 0. Or maybe it will change to 0. It will print out 100, or it will change to 0. You can see it's changing to 0 to show that truly this guy is actually changing it. Line 33 is actually changing. Let me have a printf statement before line 33. Or no, let me put my wait statement after. Let me put it here. Or no, let me just comment it out. Let me just comment it out. So I'm going to call another wait down here. So let us call wait here, not up there. So let everything inside the parent process execute first, right, before we call our wait. I believe you understand what I'm trying to do here. So I want to compile this, and then you can see now what can someone explain this output for us based on what we've discussed so far? Someone should help us and explain this before we end the session. 1 hour 33. I believe I'm still on the call. Okay. Is someone ready to help us do that?
Sure, it's good, right?
Yes.
Okay. We are all yes. Can you please go on? Can someone?
I'm thinking that wait, the statement, the wait is now at the end of the block statement. So that's why it is saying it is not. It is at the end of that. The process, the child process. I'm not sure, Sha.
Which process is this? Which process is this else?
You know, we are in the parent now.
No, I'm not saying explain this output for us. I'm not even saying you explain why wait is giving us 100.
Okay.
Explain from the beginning. Start from line 6, and maybe for someone who is watching this recording, or for others who are on this call, who can explain this output, because this output now is very different from this one. Like, it's very different, and it's still the same program. So what happened? We only changed our wait. Wait was here before, we put it here, and then we got this output. So what happened here? Can someone explain? Try and explain line by line how we got this, blah blah blah. That's what I'm asking. Who can help us do that?
Let me.
Okay.
Okay. I think what happened was the first one, the process started and then it ran.
Okay.
The line 15 was false, so nothing happened. Then line 21.
Sorry. You already skipped this one. Oh. Did this not happen? Did this not print?
Okay, yes. That line 11 happened, which is the first one. before
Okay.
calling fork function.
Which is this
But
one?
here now we equated our status to 100. So the process ran, and then the first one, it moved to the parent
Wait,
side, which is what is supposed to.
from line 11, did this run?
Yes, line 11 ran. Then
This one,
this one this one is a child process, but it's waiting for the parent's process to process first before it,
wait,
because the parent.
what is the meaning of this line? Fork RV equals to fork, then semicolon. What's the meaning of
It's
this line?
a new process that just started,
Okay.
which is just like a child process.
Who created the
So,
process?
but pardon,
Who created this process?
the parent's process created it.
That is the process we are currently running in, like the
Yes,
way you're explaining this code. Good. So on getting to this line, it executed it. It was successful. All right. Then you will move to this one now, Abby.
yes. So we moved to the other one, and it's successful. So it's false. So we passed there, and then moving to the next one. But first of all, before this one executes, the parent is supposed to finish first. So this one is going to be false. The line 21 to 29 is going to be false. So we are now going to move
Why
to the
is it going
parent's
to be
process,
false? Can you tell us why it is going to be false?
because it's a child process, and the parent's process is supposed to execute before the child process starts.
I still need more
I think
explanations.
why
Besides
it
that.
should be
I
false.
think
Why it should be false is that the fork ROV, the first value is the process ID and not 0.
Okay. Thank you.
So at the first instance, when the parent, when the parent process is still running, the value of fork ROV is the process ID of the child. So at that point, it's going to be false.
Okay.
Yeah,
Thank you.
because it's still the parents. The parents is still the one running.
Okay. All right.
So then it continues from line 31, else, then moving down. Then this other one is now going to execute printf. That's line 34. Printf, weight status of the child is. Then it's now going to give us the value that we equated the weight status of the child to, which is 100.
What about this one? You already skipped this one.
I'm explaining line 34 first. Why the output
Okay,
is
you printed this
100.
out. Okay. Sorry.
Weight status of the child is 100. So that one is going to execute, then give us
Why
the
is it
value
giving
we
us
equated.
100? As against 0 that we have here initially.
Can I
Yeah. This.
can I have a summary of the
Giving us, giving
So I
us
think
100 because
I think we've not called the weight.
I think
Yeah.
the weight call is
The
not
weight does
achievable.
not change because we said the weight will occur when we have termination or change of what state. So now there is no change of state. It means the status will maintain the value of that value at 8, which is 100.
All right.
Weight we have what? A change to what? The status when we have the termination of the child. From the manual you showed to us, you said the weight will only occur when we have termination of the child, or we have stop of the child, or when we have any changes within the process. So since in line 34 here now, the weight has not occurred. So it means there has not been any changes within the process. So it means it will still maintain the value of line 8, which is 100. So that is why it prints 100. But as for the first one we did, since there has been a change in the process state, so that's why it is 0 here because of the effect of the weight statement. But here now the weight has not occurred, so it means the status will have the same value as what we have in line 8, which is 100, because the weight will only make changes when there is termination or change of process. Or am I right? I'm just explaining based on what you explained.
You are right, but you still didn't mention a very cogent point about our comment that is here.
And here we've commented 13.
So basically, have we called weight?
No, we've not called weight here
So
now.
that's
So
the
we've commented
reason.
it out.
That's the basic reason why we are having our weights to be
So
100.
that is why it is 100 now. No, I'm just explaining based
Yeah,
on
yeah, I
we do
get your
not
point.
have this to exist.
I get your point. So the lady that was explaining, can you continue from this point now? From here. Is she still on this call? Please, if you can hear me, you can continue. The lady that was explaining. I'm still on the call now. Who was explaining before? A lady was explaining for us. Is that Victoria? All right. Can someone else explain from line 35? I just want to be sure we understand all what is happening, because we are going to be building up on this
Can I
tomorrow.
try?
Yes, please, you can go on.
Okay, so after it has printed weight status of child is 100 because it didn't see the weight there, the weight call there to change the status. All right, so the next line is I am the parent. And then it will bring that. Then the next line is my child is the process ID of process ID of the new process that was created, right? And then the PPID. Then he sees the weight there, all right? So he doesn't exit the parent. So he goes back now to the child. So at that point, the value of status has been updated.
Sorry,
so he goes back to the child now.
Sorry, from line 38.
He goes back to the child.
From line 38, where is control going to?
From line 38, control is going back to line 13.
Okay, so good. So we are now starting from here now.
So exactly, that's where it's starting from. So it checks again. It can never be -1. All right, so it definitely is 0. So it goes into the if statement and then prints those three things out.
Okay, so I think that's what we have here. I think that's what we have here. I am in the child process. Pam pam pam. These three are print Fs. So I think that's basically what we have here, right?
Yes.
Then after control has executed line 26, where is it going to?
After control has executed line 26, is that going to the return?
The return.
Is that going to the return below?
Which is this guy?
That's the end of the parent. Yeah.
Wait, we're actually running as a
because
child now.
This
is the child, though.
No.
We are not running
the
as
child
a
doesn't. The child we didn't put anything to end it there. We just also have like a return there or an exit.
Yeah. Okay. You said from here.
Yeah, at the end of the.
From here, control went back to where? To line 13.
Control went back to line 13.
Yes. Is it running line 13 and only entering this if condition without checking other conditions, or it's going to run everything from line 13 downwards?
No. He's checking now. I said it goes back to line 13, and then if he goes to line 15 and check, I said it can never be 0. It can never be -1. Sorry.
Okay.
So definitely at that point, ROV is 0.
Okay.
So the second if statement is going to be successful because ROV is 0. So it will print out those 3 printf statements.
Yes.
And when he's done with those printf statements, usually he was supposed to have an exit there. All right. So that he can exit and then go down to the parent that was waiting for it and now return out of the parent process. But because we didn't have exit there, that's why I said, okay, since the if statement has finished, ideally it will go down to the last statement, which is return 0, which the parent process is going to exit.
Okay. I think you are missing something here.
So, and there is one thing I want to point out. So maybe it is just my view, Sha. No, in the first instance, you told us that if it were to be the weight is not there, so it means we are going to have the process. It is going to return to the what? The init. You talk about the what? The init.
Okay.
So, but since when it sees this weight, it is going to return the PPID here. You can see that here we have what? 26, line 26. We have get PPID.
Okay. Yes.
So we said in that we did not have the weight. The PPID here will be what? 1. It will be referred to what? The 1, which is the what? The master init process.
Yes.
But since we have a weight here, yeah? But since we have a weight here, so it means it is not going to be a what? A floating PPID.
zombie
It will now
process.
refer back to the what? It will
Yes.
not
Becomes a zombie process.
orphan. It will not be orphan anymore. It means the PPID will be what? The parent ID, which is what weight here. So it means the parent process is waiting for the child process to finish running. Then the PPID now will be returned to the what? To the parent PID, which is what? So that's why here now we have it to be what? In the code now, we have our PPID to be what? 14920, which is the same thing as the PID of what? Which is 14920, which is no, from the result. You can see that as well we have child PID is what? 14921. The PPID of the child is what? 14920, which is the same thing as when it ran at the what? At the parent process, which is PID is what? 14920. So it means it is referring back to the what? The PID of the what? Parent. Am I correct?
Yes.
Instead of
Yes.
You're correct.
So instead of going to the what? The master init process,
Yes.
now it is now returning back to the what? PID of the what? The parent process.
Yeah, it is returning to the parent. But one thing that hasn't been stressed is this. Someone said inside this if condition, it is expecting like an exit statement or something of that nature, and it is not
It doesn't
saying it.
require that.
Yes, you
I
don't
think
need
it
to.
doesn't require that.
You don't need to put exit statement here. This is
We
it.
don't need to exit. You don't, because it will only when the parent process. Because we don't have the wait process. It means when it finishes the what, the child process, it will return. It will just return the PID to the what, to the init, the master init. But now, since we have a wait process, there is a parent waiting for it to what, get signal from the what, the child process.
Yes. And then
But
when
have you
you're
forgotten that if it doesn't exist from that place, how do you determine that how do you determine that the child process has changed so that
exactly
you can know which patient
that is
stopping it?
what I'm trying to explain now. You just have to understand that any code you are running, you have to run it till the end of the statement or till the end of your code.
And I thought the if statement we have here from line 21 to line 26, that is the statement for the what? The child process. And
The child
at the end
process,
of that curly bracket,
the child process is running everything
hello?
in this code. Oh. It's only if the condition is true it will enter. If it is false, it will not enter. Your child process is going to check this
It's going
condition.
back to
Is it breaking? My voice is breaking.
I
Okay.
said the child process will still go back to the end of the code. It will
It
run
is
everything.
going to the end of the code. It is going to check this condition. True. Checking here, since this is true, then this is false. So it's going to come here, and the first statement is going to meet is return 0. It is this return 0 that
Exactly.
will change the state of the child process. That is when your wait status will now trigger. If it doesn't meet return 0, your child process will keep running forever. That is, if the status doesn't change or if nothing terminated it, or
But it will jump that statement. It will just
the-
go from that if statement back, it will jump towards that 39.
yes,
Line 39.
because that is just normal C programming. If is correct, then else is wrong.
So it will jump to line 39. So that will return 0. That is the end of the what? The statement for what? That child process.
Let us print out something here just to show
Exactly.
us
That's the end.
that
That's the end for the
will
child process.
be
On 0.
printed. See, let me print something here. I will be printed twice. Let's have this on the screen. \n. And you know why this will be printed twice, right? Because this statement is would be executed by both the parent and the child process together. It's not inside any condition. It's not inside this if, it's not inside else. It is outside both of the conditions, which will always be true both in the parent process and in the child process. This particular line 39. So let me save this and then let me rerun my code. You can see that, right? I will be printed twice. I will be printed twice. One was printed in the parent process, the other was printed in the child process. And how can you explain this? Let's start again. Before calling the fork function, which is our line 11, then wait status of child is 100, which is our what? Our line 32. Of course, we've not called wait here. So after getting to this line, this is false, this is false. If this is false, automatically this is true. The way our if else works. If this is false, this is true. So it's going to start running whatever we have here. Then wait status of child is 100, which is what we have here, because we've not called wait. Then it's printing this, I am the parent, which is here. Then it printed this as well. Then we now waited. On hitting this wait, then the child process will be triggered. Control goes back to 13. This is false. This is false. And then, oh, sorry. This is false and this is true. So this is true. Then it printed this out to the screen. Where is it? It says I'm the child process. Then the second one and the third one, second and third. Then after this is false automatically because this is true. Then this is false. Then your child process will now print this out. If you say I will be printed twice. So the first time it's printed this out, this is inside the child process. Then control gets to return 0. On getting to return 0, the change of state has happened. Then wait will now take over and continue with the child with the parent process. So what is here? This is the parent process. Then this is the next statement that will be executed, and then return 0 will happen again for the second time. That's why we have this following themselves. If I should put my weights at the top here, maybe it would make more sense as to let me just delete it here. So both will not be printed one after the other. It will make more sense as to how the flow of execution is happening. So let me delete this. You just need to understand when a change of state would occur and which particular process you are in. Are you inside the child or are you inside the parent? Just by merely looking at the code and the output of the code, you should be able to predict which of the processes you are in. For the first process now, I'm very sure this is the child process. None of the statements in the parent process was printed out except for this one. This is the only one that was printed out initially. This is for the parent, this is for the child, this is for the child, this is for the child, then this one is for the child. Then return 0, then parent, then after return 0, wait was triggered. Then everything here will be printed, including this, then return 0, which is why we have this wait status of child is now 0 because the wait has happened. Then I'm the parent, my child PLD is this, then I'll be printed twice is this, then this would return 0. So I hope this makes more sense now with this print statements and all that.
Mr. Samuel.
Yes.
So it means from the code we wrote before, where we have the wait statement at the bottom of the else statement. Yes. So it means we should print the wait. If we should print the status there, it will be 0, not
yes.
100.
Yes, it will be 0. It will be 0. We can even print our weight at the top here, Seth. We can print it at the top here. Where is it? Okay, after the fork, I want to print out weight. So it will be printed twice, of course, because this after fork statement, right? Weight status is %d. So I want both the parent and the child to actually print this out. I want to see the type of outputs. So let me clear my screen. I think we have too many garbage stuffs here. So the first one says wait status is 100. Obviously, this is let's try and run this code before the for function call. This is the parent. Then the second one is the parent, right? Then control gets to this place, wait status. Then it goes back to this place. Then it's printed out wait again. which is the child. Then it goes inside this true condition, and it will print out whatever we have, which is everything here. Then printed, I will be printed twice for the what? For the child. That's after it has executed the if. Then it goes to line 41. Then it hits the return 0, and wait takes up the call. After hitting return 0, then wait will start, which is here. Then from here downwards, then this will be printed again and return 0. So that basically summarizes our PLD for tonight. For those who will be watching the recording, if you have questions, because you might not be able to ask questions because you'll be watching the recording, you can always ask on the Quartz 16 group, and I believe your questions will be answered. For those who are on the call, do we have any other questions as regards what we just wrote, or do we still have someone who is like completely lost in the whole concept of wait, fork, and we still have another one called sleep, but that one is very easy to use. It's just used to sleep, just passing the time you want to sleep there. Just basically you like pausing your program. Basically that's it. You can on your own, you can go to the concept page and read that by yourself. So do we have anyone who maybe has questions or additions or subtractions, or who is confused completely with everything we've been saying so far? You are lost. Wow. Like you are completely lost with everything we've been saying so far. All right. I'll stop my recording now.
You're just partly lost, but it's fine still. I'm sure eventually we'll
okay.
get hang of it.
By the time you watch the recording, I believe you will
of course,
be able to flow along.